I'm going to go through and go over each question on this study guide. If you have specific questions, make sure you just fast forward to the problem that you want to review. So number 1 says convert from degrees to radians. So how we convert from degrees to radians is we have to multiply the degree by pi over 180. So for A, I'm going to do 40 times pi over 180. So then if I simplify, the zeros cancel out and 2 can go into each. So it's 2 pi over 9 radians. For B, I'm going to do 130 times pi over 180. The zeros cancel out. And then I have 13 pi over 18. For negative 500 degrees, it's going to be negative 500 times pi over 180. So 1 0 cancels out. And then 50, 2 can go into each. So 25 and 9. So I have negative 25 pi over 9. So now for number 2, I want to convert from radians to degrees. So how I convert from radians to degrees is I just have to multiply by 180 over pi. So I'm going to multiply 7 pi over 6 times 180 over pi. So the pi's cancel out. And then I would just do 7 times 180 divided by 6. So I get 210 degrees. Negative pi over 5 multiplied by 180 over pi. So the pi's cancel out. So I have negative 180 over 5, which is negative 36 degrees. So for number 3, it says I want to sketch the angles with the given measure in standard position. So I know this is my initial side, and because it's negative, it's going this way. But negative 540... So I just added 360 that, and I got negative 180. So I know I got to go a full loop to negative 360. And then I got to go negative 180 one more. So that would be my angle. For 285, so again, start on the positive x-axis. And it's positive, so I'm going counterclockwise, and then I'm going to the 4th quadrant. So negative 5 pi over 4. So let's just think about positive 5 pi over 4. Positive 5 pi over 4 is supposed to be down here, right? So negative 5 pi over 4, so if it's supposed to be positive here, that's 1, 2, 3, 2 and some change quadrants. So I just got to go in the reverse direction. So start on my positive x-axis and then go 2 and some change to get that one. 23 pi over 6. So how I figure out this one is I just keep subtracting 2 pi. So if I do 23 pi over 6 minus 12 pi over 6, right, because that's 2 pi, I get 11 pi over 6. And I know 11 pi over 6 is in the 4th quadrant. So I just got to go a full circle. And then back to the 4th quadrant. So let's go ahead and go to number 4. Number 4 says find a positive and negative coterminal for each angle. So I'm either adding and subtracting 360 or I'm adding and subtracting 2 pi, depending if it is in radians or degrees. So coterminal means plus or minus 360 or 2 pi. So I'm going to do 160 plus 360, and I'm going to do 160 minus 360. So 160 plus 360 is 520, and 160 minus 360 is negative 200. So now if we go ahead and we look at the next one, negative 120, I'm going to do negative 120 plus 360. And negative 120 minus 360. So I get 140. No, I lied. I get 240. And I get negative 480 degrees. And then if we do C, I'm going to do negative 5 pi over 4 plus or minus 2 pi, so that's just going to be 8 pi over 4 for common denominators. So negative 5 pi over 4 plus 8 pi over 4, that's 3 pi over 4, that's 1. Negative 5 minus 8, that's negative 13 pi over 4. And those are my coterminal angles. So now if we go ahead and we talk about reference angles is the closest distance to the x-axis. So negative 120 degrees is about here. So now I want to know, okay, great, what's the distance between the x-axis, negative 180, and negative 120? Well, that's 60 degrees. Reference angles are always positive, so that's a 60 degree difference. So negative 500 is negative 360 plus 100 and plus negative 140 more, so that's where this angle is. So what's the distance between the x-axis and that value? That angle is 40 degrees. So 5 pi over 6 is over here. So that's my angle. So how this part of the x-axis is pi, so I just do pi minus 5 pi over 6. So that's 6 pi over 6 minus 5 pi over 6. So my reference angle is pi over 6. If we go ahead and we keep going, it says the terminal side of an angle if in standard position passes through the given point. Evaluate all 6 trig functions. Alright, so if I go ahead and I sketch and I go negative 1 is there, so negative 1, negative 1. So I'd have to do the Pythagorean theorem to find the hypotenuse. So it'd be 1 squared plus 1 squared. So 1 squared plus 1 squared equals x squared. So that's 2 equals x squared. So x is the square root of 2. So now I'm ready to rumble with the 6 trig functions. So sine theta is opposite over hypotenuse, so negative 1 over the square root of 2. So negative 1 over the square root of 2 is negative 1 square root of 2 over 2. Cosine theta is adjacent over hypotenuse, which is negative 1 over square root of 2, which again is going to be negative square root of 2 over 2. And tangent is opposite over hypotenuse, so is opposite over adjacent, so negative 1 over negative 1, which is 1. So cotangent is just 1. Secant of theta would be hypotenuse over adjacent, so square root of 2 over negative 1, which is negative square root of 2. And cosecant is going to be the same thing, negative square root of 2. So if I go ahead and let's do letter B. So letter B says I have to go 5, negative 3, so that's down here somewhere. So you go over 5, down 3. So I have to do the Pythagorean theorem to find the hypotenuse. So 5 squared plus negative 3 squared equals x squared. So 25 plus 9 equals x squared. 25 plus 9 is 34. So x is the square root of 34. Alright, so let's get rolling. Sine is opposite over hypotenuse. So negative 3 over square root of 34. So negative 3 square root of 34 over 34. Cosine of theta is adjacent over hypotenuse. So 5 over square root of 34. So that's 5 square root of 34 over 34. And tangent of theta is opposite. So negative 3 over adjacent, which is 5. Which means cotangent of theta is going to be negative 5 over 3. Usually negatives go in the numerator, which is why I'm putting them there. Secant is hypotenuse over adjacent, so square root of 34 over 5. And cosecant of theta is hypotenuse over opposite, so square root of 34 over negative 3, so the negative will go on the top. So negative square root of 34 over 3. So go ahead and erase this. So now we can do letter C. So letter C, over 3 up 3, so that's up here. So over 3 up 3. So to find the hypotenuse, 3 squared plus 3 squared equals x squared. So I have 18 equals x squared. And when you square root it, 18 can be simplified to 3 rad 2. So sine of theta is opposite 3 over hypotenuse, 3 square root of 2. So 3 over 3 is just 1, so it's just 1 over square root of 2, so that's just going to be square root of 2 over 2. Cosine of theta is the same thing because both these legs are the same, so it's going to end up being square root of 2 over 2 again. Tangent of theta, opposite over adjacent, 3 over 3, which is 1. So cotangent is the reciprocal, which is 1. Secant of theta is hypotenuse over adjacent, so 3 square root of 2 over 3, which is just square root of 2. And so cosecant is the same. Since sine and cosine is the same, secant and cosecant are the same. Awesome. Let's go ahead and look at number 7. Number 7 says, given sine of theta is 5 over 6, find secant of theta. So here's where I would draw a right triangle and label theta wherever you want, either that angle or that angle up there. And sine is opposite over hypotenuse. So opposite is 5, hypotenuse is 6. So now I'm going to do the Pythagorean theorem to find my missing leg. So x squared plus 5 squared equals 6 squared. So I have x squared equals 25 subtracted from 36, so 11. So this leg's square root of 11. So secant of theta is hypotenuse over adjacent. So hypotenuse is 6. Adjacent is square root of 11, so it'll be 6 square root of 11 over 11. So 8 and 9 relate to the unit circle. So this is really where you want the unit circle to be memorized. But if you don't have it memorized, you can go ahead and pull up a unit circle. So hopefully you can see that I just pulled up a browser over here with the unit circle on it. If not, don't stress out about it. It's just the picture of the unit circle. So over here it says state what quadrant in which the angle lies given the following conditions. Sine is greater than 0 and tangent's less than 0. Alright, so in order for something to be greater than 0, that means it has to be positive. So sine is positive here and here. Okay. Now tangent less than 0, so tangent's negative. So how do I find tangent? Well, how I find tangent is y over x. So when I take y divided by x, when is it going to be negative? Well, it's going to be negative when either x or y are negative. So it's going to be here or here. So since both my circles overlap there, it's in quadrant 2. If we go ahead and we look at letter B, it says when is cosine less than 0, so when is cosine negative, and when is cosecant negative. Alright, so cosine is negative when x values are negative, so that's here and here. Cosecant is negative when sine is negative, and sine is negative when y is negative, so that's here and here. So that matches up in quadrant 3. If we look at letter C says cosine's greater than 0, so when is x positive? That's here and here. And when is tangent positive, which means they're either both positive, x and y, or x and y are both negative. That's here and here. So that's quadrant 1 where they overlap. And last one, cotangent is negative. So when cotangent's negative, that's when tangent's negative. And tangent's negative when either x is negative or y is negative. So that's here or here. So that's quadrant 2 or 4. Okay? So we're going to go ahead and we're going to keep going. We're going to go ahead and evaluate some of these. Sine of pi over 4. So pi over 4 is here. So my sine value is y, so that's square root of 2 over 2. Cotangent of pi over 2. So pi over 2 is here. So tangent is y over x. So cotangent's x over y. So 0 over 1, which is 0. So the next one is cosine at negative pi over 6. Negative pi over 6 is the same thing as saying 11 pi over 6, so that's right there. So cosine is x, so the value of the x value there is square root of 3 over 2. Alright, when is your y value square root of 3 over 2? So square root of 3 over 2 is here for y, or here for y. But remember, the inverse sign has restrictions on between negative pi over 2 and pi over 2, which is these two quadrants. So it's at pi over 3. If we look, when is tangent square root of 3? So tangent square root of 3 either at 1/2 square root of 3 over 2, or square root of 3 over 2 1/2. Now, I don't have this memorized. You could have it memorized, which would make your life a lot easier. So, but how I test this is I just do y square root of 3 over 2 divided by x, so times 2 over 1. Cross them out, and sure enough, I get square root of 3. So this family right here is when tangent is square root of 3. So when x is 1/2 and y is square root of 3 over 2, that is the pi over 3 family. So, but when is it negative? So that's either here, or here. But tangents restrictions are between negative pi over 2 and pi over 2, which means it's this value down here. So that's going to be negative pi over 3, because it has to be between pi over 2 and pi over 3. Alright, so let's keep going. It says, what is secant at negative 2 pi over 3? So 2 pi over 3 is here, but negative 2 pi over 3 is the same thing as 4 pi over 3. Secant is 1 over cosine, which is 1 over x. So 1 divided by negative 1/2 is the same thing as 1 times negative 2. So that's going to be negative 2. If we keep going, for letter G says, when is the inverse of sine 1/2? So the inverse of sine so when sine is 1/2, that's here and here. But it has to be between the first and the fourth quadrant. So that's pi over 6. So now I want to know what tangent of pi over 6 is. So tangent of pi over 6 is y over x. So 1/2 times 2 over square root of 3, which is the same thing as 1 over square root of 3, which is just square root of 3 over 3. If I look at the next one, it says secant of 3 pi over 4. So 3 pi over 4 is here. Secant is 1 over cosine. So 1 over x, so that's 1 times 2 over square root of 2, negative. So that's negative 2 square root of 2 over 2, which is just negative square root of 2. And then now I have sine a negative 1 of negative square root of 2. Is that anywhere on your unit circle? When is sine, when is y square root just negative square root of 2? No? So you just write not possible. If we look at number or letter I says when is sine 1? So sine is 1. When y is 1, that's at pi over 2. So pi over 2 is y over x, so that's 1 over 0. That's undefined. So now if I keep going, three more. Cotangent of negative 2 pi over 3. So 2 pi over 3 is in the second quadrant. So negative 2 pi over 3 is the same thing as 4 pi over 3. So cotangent is x divided by y. So that's the same thing as saying 1 over square root of 3, which is just square root of 3 over 3. When is cosine 0? So when is x 0? X is 0 at pi over 2 and at 3 pi over 2. But cosine's restriction is in quadrant 1 and 2, so that's pi over 2. And then last but not least, when is cosine negative square root of 2 over 2? So that's here and here, but that has to be within the first two quadrants, so that is going to be 3 pi over 4. And now I want to know what cosecant is at 3 pi over 4. So cosecant is the same thing as 1 over sine. So 1 over sine is the same thing as saying 1 over the square root of 2 over 2, or 1 times 2 over the square root of 2, which is just 2 square root of 2 over 2, which is just the square root of 2. So now we get to go to the fun part, which is graphing all of these fun trig functions. So if I go ahead and I start graphing these, sine has an amplitude of 2. Period is 2 pi over b, which is 1/2. So 2 pi over 1/2, which is the same thing as saying 4 pi. My unit is my period divided by 4. So 4 pi divided by 4 is pi. Phase shift is what it takes the inside of my parentheses to equal 0. So x equals 2 pi. And my vertical shift is -3. So I'm going to go ahead now and label my units, and I'm going to zoom in so we can do this as nicely as possible. So this will be pi, 2 pi, 3 pi, 4 pi. So now I'm going to apply my phase shift and my vertical shift, which is over 2 pi down 3. This is where my origin now is. So sine, you start at the origin, and then you go over 1, up 1, but my amplitude tells me I have to go over 1, up 2, and then I go over 1, down 2, back to the origin, or back to the x-axis, over 1, down 2, over 1, up 2, over 1, up 2, and all the way across. And then connect your graph. So now if I zoom out to do domain and range, domain is -infinity to infinity, and your range is from -5 to -1. If I keep going, and I look at secant, secant follows the same rules of cosine. So amplitude is 4, The period is 2 pi over b, which is 2. So 2 pi over 2 is just pi. Its phase shift is what it takes for the inside of the parentheses to equal 0. Well, that's the phase shift. So that's going to be pi over 2. Unit is your period divided by 4, so that's pi over 4. And your vertical shift, I have none. So now I'm going to go ahead and I'm going to zoom in so I can graph it. So my unit's pi over 4, so 1 pi over 4. 2 pi over 4 is just pi over 2. 3 pi over 4, pi. So now my phase shift is over pi over 2, up 0, over pi over 2. So my new origin is right there. So secant follows cosine. So cosine doesn't start at 0, 0, it starts at 0, 1. But because of this amplitude of 4, I got to go 0, up 4. So right here. And then I go over 0, down 4. And because I'm at my next, I'm just going to keep going. Over 1, down 4, up 4, up 4, down 4, down 4, up 4. So wherever it hits your x-axis, that's where asymptotes of secant go. And then you just make your loops. Hopefully a lot prettier than mine. Alright, so now let's go ahead and let's talk about number 12, which is cotangent. Oh wait, no, I lied. We gotta do the domain and range. So domain is x cannot equal the first asymptote, which is pi over 4, plus or minus the distance it takes to get from pi over 4 to 3 pi over 4, which is pi over 2k. The range is negative infinity to negative 4, union 4 to infinity. Cotangent follows the same rules as tangent. So cotangent amplitude really doesn't have one, but you could also say it was 1. The period is pi over b, and since b is 1/2, pi over 1/2 is the same thing as saying 2 pi. Unit is period divided by 4, so 2 pi divided by 4 is the same thing as saying pi over 2. Phase shift, what takes the insides to make 0. Add pi, multiply by 2, you get 2 pi. And vertical shift is up 3. So let's go ahead and start graphing this. I'm going to go, my unit is pi over 2. So pi over 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So my origin is over 2 pi up 3. So with cotangent, your origin is always your first asymptote. And then it's 1, 2, 3, another asymptote. And then it's 1, 2, 3, another asymptote. 1, 2, 3, another asymptote. 1, 2, 3, another asymptote. Because cotangent is negative, it's increasing. So I go and find the distance between your two asymptotes in the middle. And then it's going to be over 1, up 1, over 1, down 1. And then same thing in the middle, over 1, up 1, over 1, down 1. And I just have to make sure it's increasing. And I make my loops. So if I do domain and range, domain is where x cannot equal, where your first asymptote is at 0, plus or minus the distance to the next one, which is 2 pi k. Range is all real numbers. So now if we go ahead and we do number 13 is cosecant, which is the same thing as sine. So, or it's the same family as sine. So the amplitude doesn't really have one, but you could also say it's 2. Period is 2 pi over b, which is 4, so that'll be pi over 2. And then its unit is period divided by 4. So pi over 2 divided by 4 is the same thing as saying pi over 8. Phase shift makes inside parentheses equal to 0, so that'll be pi over 4. Vertical shift is 1. So we go ahead to start graphing. My unit is pi over 8, so 1 pi over 8. 2 pi over 8 is pi over 4. And then we have 3 pi over 8. 4 pi over 8 is pi over 2. 5 pi over 8. 6 pi over 8 is 3 pi over 4. 7 pi over 8, and then 8 pi over 8, which is pi. So now I'm good to do my origin, my phase shift, and my vertical shift. So over pi over 4, up 1. So here's where my new origin is. So sine starts at 0, 0, and then I go over 1, up 1, but because of this 2, I got to go over 1, up 2. Over 1, down 2, over 1, down 2, over 1, up 2, over 1, up 2, all the way across, alternating. And because this is your makeshift origin, this is your makeshift x-axis, so everywhere it touches the new x-axis is where there's an asymptote. And then you just draw your loops. Should be going through those points. Terrible drawing on my end. So now if we go ahead and we do domain and range, domain, x cannot equal, wherever your first asymptote is, so 0, plus or minus the difference to the other one, so pi over 4k. The range is negative infinity to negative 1, and then 3 to infinity. Alright, tangent, amplitude, there isn't one. Period is pi over b, so pi over 3. Unit is pi over 3 divided by 4, which is pi over 12. Phase shift is 0, and vertical shift is 2. So 1 pi over 12, 2 pi over 12, which is pi over 6. 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. 5 pi over 12, 6 pi over 12, which is pi over 2. And I'm going to stop because my phase shift is 0 up 2. So that's where my new origin is. Tangent always starts at the origin, and then it goes over 1, up 1. Because of that 2, I'm going to go over 1, up 2, over 1, down 2, and then next to it is an asymptote. And then same thing, it's going to be 3 spaces in between, asymptote. 3 spaces in between, asymptote. So in the middle, over 1, up 2, over 1, down 2. you just repeat that same graph. So now, if we go ahead and do domain and range, domain is when x is not equal to the first asymptote, which is pi over 6, plus or minus the distance to get from pi over 6 to pi over 2. So pi over 2 minus pi over 6. So that's going to be 2 pi over 6, which is pi over 3. Pi over 3k. Range is all real numbers. If I go ahead and do number 15, number 15, amplitude is 3, period is 2 pi over b, which is pi, unit is period divided by 4, so pi over 4, phase shift, what makes the inside 0, pi over 2, vertical shift is 0. So now if I zoom in so we can graph it nicely, my unit is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So I'm going to go over phase shift pi over 2 up 0. So my new origin is right here. So cosine usually starts where? 0, 1. But because of this 3, it's going to start at 0, 3. And because it's negative, I go 0 down 3. And then go back to the x-axis. And then go over 1 up 3. Back to the x-axis. Over 1 down 3. Back to the x-axis. And so on and so forth. And then connect your dots to make a cosine graph. So now if we do domain and range, domain is all real numbers, and range is from -3 to 3. If we keep going, let's talk about some trig identities, but before we do our trig identities, we want to simplify. So if I go through and I simplify, they need to have common denominators. So I'm going to multiply this side by cosecant of theta, and I'm going to multiply this side by secant of theta. So here I have cosecant of theta, cosine of theta, plus sine of theta, secant of theta, all over secant theta, cosine theta. So now secant is 1 over sine, so that's cosine theta over secant, cosine over sine, plus sine of theta over cosine of theta, all over 1 over cosine theta sine theta. So now if I come over here and I find a common denominator between these two, I'm going to multiply cosine over here, and over here I'm going to multiply sine. I'm going to have cosine squared theta plus sine squared theta, all over cosine theta sine theta, times the reciprocal of that, cosine theta sine theta all over 1. So those cancel out. Cosine squared plus sine squared is 1, so simplified to 1. Erase so I have some room over for letter B. So sine times cosecant, so that's sine of x times 1 over sine of x, plus sine squared over cosine squared, well that's tangent squared. So these cancel out with 1 plus tangent of squared, which is secant squared. Verifying trig equations, so split it up and choose one side to focus on. I'm going to focus on the left side. Tangent squared plus 1 is secant squared over secant. So these cancel out, so I'm left with secant x equals secant x. If you go over and we look at this next one, you can do this in a bunch of different ways. I'm going to choose the left side to focus on. You can distribute this in if you want, but I noticed tan squared plus 1 is secant squared. So now I have cosine squared x times 1 over cosine squared x. So these cancel out, so I'm left with 1 equals 1. If I look at letter C, I'm going to focus on the right side. So I'm going to factor out a cosine. So I'm left with 1 minus sine squared x. So now I have 1 minus sine squared x is cosine squared x, which is the same thing as saying cosine cubed x. If I look at letter D, which side is uglier? That's the left side. So cosecant is 1 over sine of theta. Cotangent is cosine over sine. All over tangent, which is sine over cosine, plus sine theta. So the top is going to be 1 plus cosine over sine times the reverse. Well, and if I find this, that's going to be sine cosine over cosine. So that'll be times cosine over sine plus sine cosine. So now I can factor out a sine on the denominator. So I'm left with 1 plus cosine. So those will cancel out. So now I'm left with 1 over sine plus, not plus, it should be a times here, plus cosine over sine, which simplifies to cosecant, cotangent. So what's left is solving trigonometric equations. So number 18 says write the general solution to the following. So I have to get x by itself, so that's going to be, I have to first square root, so x equals cosine of x equals plus or minus 1. So when on my unit circle is cosine plus or minus 1, that is here and here. So that's at 0 and pi. But to write the general solution, I have to do plus or minus 2 pi k, or plus or minus 2 pi k. Or you could have technically wrote x equals 0 plus or minus pi k, because every pi it's working. Every pi satisfies that equation. So 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. For b, I'm going to add 1 and then divide by the square root of 3. So that's square root of 3 over 3. So I have to think about on my unit circle, when is tangent square root of 3 over 3? When it's positive. So it's positive, tangent's positive here and here. So square root of 3 over 3 is in the pi over 6 family. So it's going to be pi over 6, and then down here that's 7 pi over 6, and then plus or minus 2 pi k, plus or minus 2 pi k. For number 19, it says find the solution of the trig inequation through the given interval, 0 to 2 pi. So now A, I'm going to factor out a sign. So now I'm going to split up my two factors. Sine of x equals 0, and sine of x equals -1. So on a unit circle, when is sine 0? Sine is 0, so 0 is, sine is, y is 0 here and here. So that's at 0 and pi. So those are two solutions. And when is sine equal to -1? That's down there. So x also equals 3 pi over 2. If I go over and do letter B, I have a cosine squared and a cosine, which means I'm going to have to factor because I also have a constant. So I'm going to add 4. So cosine squared x plus 5 cosine plus 4 equals 0. So it's going to be cosine x and cosine x. Factors of 4 that make 5 is 4 and 1. Split up your factors. So cosine x equals -4, which is not on my unit circle, so that's not a solution. And then here, cosine x equals -1. So when it's cosine -1, that's right there, which is at pi. If we keep going, sine squared plus cosine equals x. Because you have two different trig functions, I encourage you turn one of them. So since sine squared is a trig identity, I can do 1 minus cosine squared plus cosine equals 0. Nope, equals 1. If I subtract 1 on both sides, I have negative cosine squared x plus cosine equals 0. So now I can factor out a negative cosine x. So I'm left with cosine x minus 1. Split up my factors. Negative cosine equals 0, which is the same thing as cosine equals 0. And cosine x plus 1 is cosine x equals 1. So when is cosine 0? Well, its cosine is 0 at pi over 2 and at 3 pi over 2. And when is cosine 1? At 0 or 2 pi, but my interval is only between 0 and 2 pi, but 2 pi is not included, so it's just those. For letter D, subtract 5, divide by 5, I get -1. So when is cotangent -1? Whenever you get 1, it's one of the pi over 4 families. So cotangent is going to be negative when tangent's negative, which is the second and the fourth quadrant. So that's at 3 pi over 4 and at 7 pi over 4. Letter E, I would subtract 3 tan of x. I'm not going to take out a tan. So I'm left with tan squared minus 3 equals 0. So here, split up my factors. Tan of x equals 0. And now I have tan squared x equals 3. So tan of x equals plus or minus square root of 3. So tan is 0 when y is 0. Y is 0 and 0 and pi and 2 pi, so that's just 0 and pi. Square root of 3 over, no, I'm sorry, just square root of 3 is, my answer key is wrong on this. Square root of 3 is the pi over 3 family, so pi over 3, 2 pi over 3, 4 pi over 3, and 7 pi over 3. And then last but not least, 4 sine squared. So I would divide by 4. So I have 3 divided by 4, square root. I have sine of theta equals plus or minus square root of 3 over the square root of 4, which is 2. So everywhere y is the square root of 3 over 2 is pi over 3, 2 pi over 3, 4 pi over 3, and 7 pi over 3.